Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 14th, 2025, which was just 2 days ago. The big idea is a single post-keyframing stage that fuses inbetweening and colorization, producing high-quality, temporally consistent cartoons from only a sparse sketch and a colored reference frame. The paper is titled ToonComposer, Streamlining Cartoon Production with Generative Post-Keyframing. And as we'll see later, the results are really impressive. In short, the model brings precise control through sparse sketch injection and a spatial low-rank adapter, beating prior two-stage systems in visual fidelity, motion smoothness, and production efficiency. Building on that, tweets highlight ToonComposer unifying inbetweening and colorization with sparse sketch control, calling it a workflow shift for anime production. Engagement looks decent, with around 130 likes on one post. Alright, this opening figure showcases the workflow in action. From a single colored reference frame and a few sparse sketches on the left, the rows to the right expand into full video sequences with consistent style and smooth motion. Building on the post-keyframing idea, the top and bottom examples generate 33 frames, while the middle example stretches to 69 frames, demonstrating flexible length control. Notice how the sketch timestamps align with the resulting poses, indicating precise keyframe guidance across large motions. Next, this diagram contrasts the old pipeline with the new workflow. Focus on the full graphic. The top row shows the previous approach, where sparse keyframe sketches go into an in-betweening model, produce per-frame sketches, then feed a separate colorization model. Building on that, the bottom row collapses everything. A colored reference frame plus a few sketches flow directly into ToonComposer, which outputs the final cartoon video, preserving motion and style while skipping error-prone intermediate steps. Okay, this architecture diagram walks left to right. First, the VAE encoder turns 3 inputs into latents, input noises, a colored reference frame, and sparse sketch keyframes. Next, the sparse sketch injection block aligns sketch tokens with video tokens via position encoding, then adds a position-aware residual to steer motion at chosen timestamps. Building on that, the diffusion transformer runs with spatial low-rank adapters, adapting only spatial style while keeping temporal dynamics. Finally, projection and the VAE decoder produce the output cartoon video. Moving to the results, this table compares 4 systems on the synthetic benchmark, listing perceptual and video quality metrics side by side. Lower is better for LPIPS and DISTS, while higher is better for CLIP, subject consistency, motion smoothness, background consistency, and aesthetic quality. ToonComposer leads across the board, with a notably low DISTS and the highest aesthetic score, indicating stronger perceptual fidelity and cleaner temporal coherence than AniDoc, LVCD, and ToonCrafter. Continuing with the numbers, this table reports results on the real sketch benchmark, using reference-free VBench metrics. Focus on the overall grid. Higher is better for subject consistency, motion smoothness, background consistency, and aesthetic quality. Across all 4 columns, ToonComposer posts the strongest scores, edging out AniDoc, LVCD, and ToonCrafter, especially on motion smoothness and aesthetic quality. The takeaway is clear. With only human-drawn start and end sketches, the system maintains style and produces smoother, cleaner motion. Wrapping up, 2 takeaways stand out. First, unifying inbetweening and colorization into post-keyframing sharply reduces manual steps while improving motion and style. Second, sparse sketch injection and the spatial low-rank adapter let artists guide timing and appearance with minimal input. Diffusion transformer means a diffusion-based transformer backbone. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.